Thank you, and thank you for a very interesting presentation. And you are correct. At least I'm more talking about how to limit the information that people would get or organizations would get from IoT. But let's look at a bit of background. IoT is not a new thing. This is a picture from about the year 2000 from a project I initiated then, and it was all sorts of sensors, and you could see what people are actually doing in their bedrooms at night, whether they are moving or not moving, and from mobile phones you can, for example, with big data from people's mobile phones, you can give a couple of minutes prediction on earthquakes. That you can call them and say that now get out if you are in a building. But if you give that information, you also give access to information that predicts if you have Parkinson's. Or if you have the mobile phone here, it shows if you are having a heart attack. The mobile phone GPS information, or not GPS, but the information on the mobile phone's position gives very much information on everything. But let's go on. What has happened is that the devices used for building IoT has become cheaper and cheaper and cheaper. Currently, it's about $5. You can buy a device that has Wi-Fi connectivity, and it has Linux on top of it, and it has sensors and so on. $5, not much, and the price is going down continuously. You can have small devices. This device is making your DNA analysis, full DNA. 10 years from now, I can take anyone's DNA without you noticing. Talk about privacy. I'm pessimist on privacy. I think it's a foregone conclusion that we should have any privacy. The best way to make the world secure would be transparency, but I'm still running a project where privacy is the intention of the privacy, because there are some things where we actually need them. But very many things driving now IoT, and very many uses, and we accept them, and we accept the loss of privacy because it's very difficult to live without these things in the future. Now, one example of a new method of delivering packages, which is now being done in Norway and in Germany. DHL, if you order a package from DHL, or DHL delivers the package, if they know that you have a Volvo, you check the box, you wish the delivery to your Volvo. DHL reads that information, checks where your Volvo is currently. You give them access to the position information. Instead of delivering the package home to you, calling you that you must be available at home from 3 p.m. to 5 p.m. to wait for the package, you give access to your Volvo. They search where your Volvo is. They get one one-time key to the luggage department of your Volvo. They open it and put the package in there and close it, and there the package is in your car. And lots of information you gave them because this was easier for you. This is how it works. But the thing I want to talk about more is not devices that are actually connected to internet or sensors or intelligent electronic devices, but things like old stupid cars with their license plates, things which are identifiable as individual things, where somebody does maintenance on your car, somebody produces you some stuff, and all those things, the information on the transaction is shared between one individual and another individual who both are entitled to that information. So Mydata is easy when it's a large company, it's anonymous data for the company, and only you are interested in that it's your information. But when the information starts being more typical of human society, that the products are individual, there are several people interacting with the same device. The information is shared. We need policies where the information on that thing is stored, where the information, who has used the thing, who has maintenance the thing, who is allowed to access the thing. The data needs not to reside in any organization, it needs to reside in the thing. And if it is a passive, stupid thing, a cloud service will do. It needs not be an active device. Then you can also access the data when the thing is not in front of you. But the things need to be identified. So we need to identify things. We don't need to identify people, but we need to identify things, and we need to authenticate people to provide them access to their thing-related data. This is a result we got from with Ossi Kuittinen doing a report for Finnish Transport Agency, coming up with an architecture where people have identities, devices have identities, and stupid old things have identities. And if this is true, then we can have services like anonymization based on this, and the applications that organizations have no longer get our identities connected with their databases, but the organizations get anonymity. It is before the organization, not after it. And this is quite a different approach. This is the object-oriented approach where individuals are objects, individual things are objects, and so on. And this is the basis of thing-to-data architecture. And we started from the point that every single thing would have identity, whether it is a coffee mug or a contract or a movie ticket or a car or an engine in the car or luggage or whatever. But we ended up understanding that in this architecture also people are things. So everything in thing-to-data architecture is things. Also organizations are things. One example would be that if you buy a coffee mug from the network, the one who sells it transfers ownership to the coffee mug to you. Then from your Mydata information, the destination you wish is imprinted to the coffee mug. The one who picks up the coffee mug for delivery reads the identity and gets the destination data and gets payment from the coffee mug for the transportation. But the idea here is that the sales guy never gets the information on the destination. They might not even get the name of the buyer. And the first guy who delivers it does not get information on the final destiny, but could only get the information on the locker where it's left. So this hides information, doesn't reveal information to organizations, but hides it. Information is need to know basis in the sense. Several different examples, but the architecture we created, it's identifier independent, so you can use any kind of identifier, whether it's QR code or some sort of beam or license plate, whatever. Access it with your mobile device or operate on the information from the large corporation systems. But it's also server independent, so we call the data storage, we call them inventories. Anyone can set up an inventory, and the inventory where you initially create the thing, the identity gets the first inventory's URI in the beginning. But if the user wants to move the data from this inventory to another inventory, somebody else's inventory, then the identity doesn't change, but we enter the transfer transaction to blockchain. And if you don't find the information from the first inventory where it was created, you ask blockchain where it has moved. Now, the rights and roles, every single thing defines roles, and for each role it defines what data that role can access, and for each role it also defines who belongs to this role, what other thing belongs to this role. You have sort of access chains, and because you can have this sort of access chains that the car is allowed to know where its wheels are, and so on. And the driver is allowed to know what the car is entitled to know. Then the logging and privacy for logging becomes, I would not say complicated, but there are many problems that need to be solved in very different way from old kinds of architecture. And now we have done that in the middle of this summer. I thought that perhaps it's not possible, but now I know that it's possible, and we have had steering groups evaluate the solutions we created, and they are efficient. The architecture is NoSQL compatible, so it's scalable to everything being individual things. But something else still, it's API. The API will be open data. We give access and full rights to the source code to every consortium member who, part of them, for example, Helsinki has announced that they will give it to open source code license, and I think I'm in the end of my time. If you have questions.
Hey, thank you, Risto. I'm sure there are some questions, so please.
I think we saw on the back channel something.
So
movie tickets.
yeah, there's the first one. I think. So movie tickets are things, and people are also things. People do stuff. So do movie tickets do stuff?
We have lots of things that only require the access, and they can be marked as used and so on. So they are objects, and people do things to those objects, and they are not sort of active. So some things are active and some things are passive, and some things are just abstractions, only like organizations. That is only people, but still they can be called as things, and you can be allowed to the access. And if movie tickets or electronic tickets are individualized and they have owners, you can't steal them from the pictures. You can't just by seeing the QR code of the ticket, you can't steal it because you don't own it. It's so currently we have ridiculous systems where everything that is digital can be stolen from you because it's not connected to your identity. We need to connect the access rights to the individual, but we also need to anonymize the connection.
Okay, I have a related question to that. So how do you have any practical example of how these things actually scale? Some if you start issuing the identity and the access rights to different things, what does it cost in a practical case?
The volume of data is not, it's small. It sort of depends on how much it costs to store a few thousand bytes of information. I think it's a question of well, a lot less than Facebook or Google is charging you. They are charging nothing. It can be run on charging nothing, just covering it with advertisement or things, but we don't have the commercial models yet. We we sort of provide the technical platform and we allow others to create various models.
Okay. Okay, thanks Risto. Let's give hands to Risto. So we move ahead in the program. There's a slight mix in the program. The pictures and the text were in a different order, but let's take Christian next. So Christian Backström comes from a company called Control Things. It's a Finnish SME, and he's an expert on IoT. I can share that, but maybe you tell a little bit more about yourself and then about the things you have done in Control Things.
Yes, thank you, Pete. Sure, I have a background both from building automation and computer science, but now I'd like to discuss more what Control Things has achieved. Control Things is an SME from Porvoo, Finland, 50 kilometers from east from here. And we developed connectivity. This connectivity is intended for any kind of IoT. With IoT, I not only mean small devices, but anything that is IP connected and both large and small systems. So the connectivity targets both device manufacturers and system developers, of course smart cities, etc. But I will first start with, I will describe two examples. The first one describes more what our solution is, and the second example will describe more how it applies and how it relates to the Mydata concept. So this first example, it's taken from an ongoing project where we have cooperation with BMW, Helsinki City, Brussels City, Lyon City, and a couple of other stakeholders. There are 22 companies. It's a Horizon 2020 project. Let's say, imagine that we have a car, a smart car that wants to consume service. It needs to recharge and park. And then we have the smart cities who want to provide information about these available services. So neither one are actually appropriate to host such a service, as it needs to scale up for every city in the whole world, and of course for every brand everywhere. So within the project we are now, this is actually part of other partners of the project. They are developing a service catalog for automated consumption of services in order to discover and publish any kind of service, IoT service, for smart things. Parking lots, charging stations are good examples, and we will work on that. We will also work on interfaces for both publishing and discovering and consuming these services. So the car asks what's available, what kind of services are available. It looks up from the service catalog. They could be several in parallel, and they could be crawled as well, so no one gets in power position. It finds a service provider, a charging station, and a parking slot. And our expertise, our connectivity comes in here, in both ends here, both the service provider and the consuming part. So what we've done, we have a connectivity which provides a convincing identification, authentication, and an authorization. So you have also an access control, how much information you share between devices. and this is completely distributed, where no one is in power position and no implicitly trusted third parties. This means that we don't have any particular predefined certificate authority, for instance. And this solution can also run really on very tiny embedded smart devices. So let's take the other example, see how this fits and what it brings for Mydata concept, how it relates to the Mydata concept. Currently, this is the typical situation, as we are very aware, that service providers are collecting a lot of information and they're storing them. Let's imagine medical records, purchase records, calls, SMS, geographical tracking, etc. They're collecting private information about you, and typically it's hosted by the service provider. So the alternative, what this connectivity could bring, when you have an interoperability and connectivity which can provide authentication, technically it opens up possibilities that you could receive all logged data to some place where you point out yourself. So you could decide to store it, for instance, at home or at some particular storage service provider, but you could receive this digitally signed by the ones that have collected the information, and in that way, once the user has the data, receives the data, you can imagine that how it turns everything upside down, because first of all, he's in control of the data. If this, let's imagine a situation where these have provided you with the data and haven't stored it themselves, then he can kind of pipe it back when they need it. If they want to request data, they need to do it via him. And okay, this can be in another particular cloud, but he can put up kind of a firewall, automated rules for what's allowed, disallowed, and you can also be alerted on particular requests in order to take action when that request comes. However, yeah, the end user is now in control, and what's really interesting here is the new amount of context you receive with the data. So you can imagine how much better this environment is for creating a personal agent, smart behavior based on your own data which has been collected. But of course, this is what the technology can enable, but it's probably not likely that these collecting providers volunteer to do it. So one suggestion, one idea, it's quite long shot, but through regulation in the last end, it would be possible to regulate that the user could be able to decide himself where he wants to store his data. And this could, of course, this service provider still store data, but only anonymized, so that they wouldn't connect it with particular users. When it's connected to a user, it should be up to the user himself. So this is how I see that our technology relates to the Mydata. It could enable up this, but it cannot enforce it. So let's see what we've done, what can enable this. I mentioned already the authentication. Our solution has an authentication when no one is in power position. I see if you want to build a secure system, the only way to achieve it is to avoid external identity providers. You need to generate your identities on each thing itself in order to be sure that you have exclusive access. Otherwise, you are trusting some identity provider. The trust can be okay for situations where you're the only stakeholder on the system. But if you're developing a system, a communication which should scale up for any system, many systems have different stakeholders and many different kinds of organizations which doesn't necessarily share the same trusted third parties. So no one has the implicit, no one is, there's no implicitly trusted third parties. This about authentication, it's basically it's public key cryptography. And then interoperability, we're really in the bleeding edge on this with interoperability, as our CEO is also a chairman of a standards organization, the Open Group for the IoT work group. And yeah, this is the Horizon project I mentioned earlier is all about interoperability between systems. Interoperability requires, of course, that you have a domain agnostic API which has no semantics, vocabularies included or defined, but they are just referred to. This is part of it. But then after, finally the access control, when you're connecting systems in any direction, you always need to be able in both ends to decide how much of the information should be shared between the systems in each direction. So if this is the solution we've used to see the cloud-oriented solutions, what we add on is a peer-to-peer communication where each system can be paired together with any other system, and you define the access control. We call it system systems, and it can be, as I said, other big data sets or cloud services, but it can also be tiny small devices. So these are domains that we're currently active in. We're a small SME, so we need to focus, but we have, these are results of such where we have either achieved deals or got funding for. So this reference application is it's a basis for several user interfaces. We have one generic $2 Wi-Fi module which can be integrated into third-party products. So it includes the connectivity stack. I need to emphasize once more that we're not a service provider. This can be added in parallel with other existing solutions. So we're not married in any way. But then we have a customer which we're integrating currently into their devices. We'll hit the market in Q1 next year, approximately. And then within the project we have this with mobility and service providers and service catalog. But this is about it. Okay, thank you.
Thank you.
Questions?
You talk about interoperability, but you never talk about service discovery. How do you actually perform service discovery?
This is a trust-based networking what we are building. So the service discovery in the first example, for instance, was made via the service catalog. But within our trust-based network, there's actually no discovery of new sources. You need to pair them and couple them together itself. It's not a web of an open web. You're establishing new connections by pairing them together. So you're not open in that sense.
Okay, further questions?
Okay, maybe I make one question still. So I always want to ask the practical side of things. I mean, you had a couple of domains where you have tested this, and I mean, it's just, I'm curious about how all these things actually scale. So if you think about the, for example, the meter, you have the parking readings application. I mean, do you have any issues about scaling it up? So I mean,
No, this is a peer-to-peer thing, so it scales incredibly well. It scales much better than cloud-oriented.
okay, good. All right. If no more questions, I think that in the interest of time we move ahead. Thank you, Christian.